Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question extracted from 2018 Time Zone 0 in November. Question number 9, stuff related to topic 4 about molecular geometry deduction. So or simply means the shape deduction of a molecule. Let's see. So asking, which species of the following has the same molecular geometry? So we are now looking for the same molecular geometry as our subject today, SO32- are what we call sulfide ion, SUL-PHITE or SUL-FITE, right? A sulfide ion. So first of all, no doubt that student must be able to know the molecular geometry of sulfide and be able to know a species or molecule or ions. Molecular geometry, the first step is that we must be able to locate the Lewis structure, or what we call the electron dot diagram. So in this case, better if we can sketch the electron dot diagram of sulfide ion first, right? So that will be with a central sulfur, and then remind you 6 outermost shell electrons, right? So 1 with a double bond with an oxygen, so simply like this, and 2 of the oxygen with additional electrons, right? Because we need to first assign the negative charge to those elements first. So no doubt that the 2 electrons should be each assigned to each oxygen, right? Why? Because if both electrons are assigned to sulfur, supposedly sulfur has already met the octet rule. So meaning that it is kind of meaningless for us to assign electrons to sulfur, but to oxygen. So with this perception that each oxygen will receive 1 extra electron, so like works now like a group 17 element, which needs only 1 bond to be satisfied, but remaining free of the lone pairs, right? Yeah, but remember, don't forget about the lone pair electrons on the sulfur, because sulfur is a group 16 element having 6 outermost shell electrons, right? So in this case, 4 of them are being used to form covalent bond, so remaining still 1 lone pair. Don't forget about that, otherwise you cannot arrive to the right answer. So obviously the entire thing having 2 negative charge. So right after finishing the structure of the Lewis structure, then what do we do in the next step is try to locate the central element. So in this case, central element obviously is the one appear with the least times, so which is sulfur. Around this central element, the total number of electron domains. So I'm pretty sure that students should able to know what is meant by electron domain, counting on the lone pair and also the bond pairs, right? But remember, multiple bonds count as only 1 domain. So that is also the reason why we call it domain, but just not simply call electron pairs, because multiple bond pairs still count as 1 domain. So in this case, we have 1 domain, 2 domain, 3 domain, and 4 domains. So altogether 4 domain, with equivalent to 3 of them is a bond and 1 of them is a lone pair. So with this idea, we have the spell 4 equals 3 plus 1. So with this perspective, that we should refer back to the table that we should have memorized before. 4 equals 3 plus 1, which is a trigonal pyramidal. Trigonal pyramidal situation. That is simply means the structure like ammonia, right? The really famous example that students should learn at the very first beginning, right after understanding the concept of trigonal pyramidal. So which now breaks down to the question, which of the following species has the molecular geometry like a trigonal pyramidal, right? So with this perception, then let's look at each of the choice. The first one, BF3. So no doubt, first of all, again, the Lewis structure. Boron comes in the center with 3 of the fluorines adjacent, right? And all the fluorines having lone pairs. And boron has already finished is all the electrons using to form the bonds. Although it is not an octet structure, still this is going to be the only possible Lewis structure. So that's why this is only be a 3 equals 3 plus 0 situation, counting on the central element. 3 of the domains, all the domains are bond domains, right? So that's why no lone pair. So that's why obviously not with our spell, so that's why not the choice. Next, SO3. So I draw this out. So with a central sulfur, and then this time with 3 independent oxygen with no net charge, right? So simply means each oxygen must be having a double bond, right? In order to match the octet. But in this case, sulfur is having an extended octet, but it is okay because sulfur has more than enough vacancy that it can accumulate more electrons, right? So in this case, although sulfur has formed altogether 6 bonds in having like 12 electrons surrounding the outermost shell, it is still be okay, right, to be having extended octet. But counting on the electron domain of the central element, still 3 domain in total, and all of them are bonded domain. So that's why still with the spell 3 equals 3 plus 0. So still not our choice because we want 4 equals 3 plus 1. So let's look at the next choice, PF3. So in this case, if we look at it, phosphorus is having the central, and this time having 3 fluorines again. Looks pretty similar to option A, but the thing is, remember, phosphorus is a group 5 element. With a group 5 element, after forming 3 bonds, there's still 1 lone pair. 1 lone pair left, right? So meaning that within the central element, phosphorus, we have 1, 2, 3, 4 domain this time. And the 4 domain will be equivalent to 3 of them are bond, plus 1 of them is a lone pair. Exactly like our spell this time, 4 equals 3 plus 1. Works exactly like ammonia, with the central nitrogen having 3 bonds with 1 lone pair, right? So that's why obviously the answer should be C. But let's double check it for finally D, right? Maybe I sketch D right a bit further here. Yeah, the carbonate ion. Still, this time the carbon, which is the central, right? And obviously, again, the same logic. 2 negative charge should be going directly to each of the oxygen. So that's why one of them is a normal double bond, right? With a 2 lone pairs, right? And then 2 of them having only 1 single bond, and then with 3 lone pairs, right? Hope you can observe it. And then finally, this is the structure of a carbonate ions, right? And the whole thing, which is of 2 negative charge, right? 2 negative charge. So this is the Lewis structure of the carbonate, right? So that's why if we count on again the central element, carbon, still 1, 2, 3, 1, 2, 3, 3 domains in total. No more lone pair. So 3 equals 3 plus 0 surrounding the central element. So that's why I can see both A, B, and D, these 3 are just having a 3 domain case with 3 plus 0, no lone pair situation, which is going to be trigonal planar. But the answer for this case will be C, having the same molecular geometry as our subject, sulfide, which is a trigonal pyramidal situation. So from this question, what I want to brainstorm is about that the way for us to decide a molecules or an ion, polyatomic ion, geometry is that we should be using the steps. First, decide the Lewis structure, the electron dot diagram. Second step, count on the central element, the total number of electron domains. And finally, give rise to a spell or equation that the total number of electron domains that we counted equivalent to how many of them are bond and how many of them are lone pair. And so eventually give rise to an equation and search for this equation that which of the following choices will be matching, and that will be our choice. So in this case, answer will be C.